Hello, Jeff Zwerink, and welcome to Give and Take, the segment of our show where we explore important scientific ideas and how they relate to the truth of Christianity. Today, we're joined by Reasons to Believe's founder and president, Dr. Hugh Ross, and we're going to be discussing how ice ages affect human civilization. Hugh, good to have you on the show today.
Well, thank you.
So kind of just give us a little bit of an overview. What are ice ages? How do they look like? What are their basic features? Just help us to understand ice ages a little bit.
Well, we're talking about an ice age cycle. I mean, for the last 2.5 million years, we've always had ice.
Okay.
But the ice cycles from about 10% coverage of planet Earth to about 20 to 23% coverage.
Okay, so presumably, we got ice at the poles, and during the 20% coverage, it grows and covers more of the surface of the Earth?
Yeah, most of North America, a lot of Northern Europe and Siberia.
So presumably the temperature of the planet varies fairly significantly during there.
Right.
Roughly what sort of temperature variations do we see in that?
Well, it's about anywhere from 12 to 15 degrees. I mean, about 12 degrees centigrade.
The coldest to the hottest?
Right, but it does vary a lot in between.
Does vary a lot in there. Okay. So something happened about 800,000 years ago that affected this ice age cycle that I know you think is pretty important. Well,
what happened is that it transitioned from being a 41,000 year cycle, driven by the variation of tilt of Earth's orbit or orbital axis, to about 100,000 year cycle.
Okay, so we would go from ice age, interglacial ice age in 41,000 years, and that shifted now out to about 100,000 years.
Right, so the cycle got lengthened from a 41,000 year periodicity to about 100,000 years.
And why is that important?
Well, it's important because it'll actually give you a longer period for an interglacial.
Interglacial being?
The warm period, when you only got 10% coverage.
Okay.
And with a 41,000 year periodicity, you're looking at a warm interglacial that lasts maybe just 3,000 years.
Okay.
Whereas if you got a 100,000 year periodicity, it can last 10,000 years. And if it lasts 10,000 years, that gives you time to launch and sustain global high technology civilization.
So it seems like there may be two effects going on in there. One is that the period between the ice ages gets longer, and it's kind of remarkable. We spend most of the time in the ice age. There's a very little time in between the ice ages. Is that correct?
Yeah, that's 90,000 years where you got 20% coverage, and only 10,000 years where you got 10% coverage. So most of the time you're in what's called the glacial. You only have brief times in the interglacial.
So you got a longer period in the interglacial, and presumably a longer period will also bring more stability of temperature within the interglacial, or is that not true?
Necessarily.
Not necessarily.
I mean, the last 8 cycles have been 100,000 year cycles.
Okay.
It's only this one where we've had climate stability in an interglacial.
And so what would climate stability look like? How would you characterize that compared to the previous interglacials?
Well, what you see throughout the ice age cycle is the global mean temperature jumping up and down by about 10 degrees centigrade, 18 degrees Fahrenheit on timescales of several centuries.
Okay.
Which basically makes it impossible to launch large-scale agricultural activity.
Okay.
Which is going to limit civilization.
Right.
What has happened in the last 9,500 years is we've had climate that's been stable to plus or minus 0.65 degrees centigrade. And it's that extreme and long-lasting climate stability that has enabled us to build a large human population and to have global high-technology civilization.
So I'm presuming there's not just one thing that causes this, or would be fairly easy to explain. What are some of the factors that go into explaining this? Because it seems like it's pretty important for humanity to have made this transition.
Well, Jeff, there's been a long debate in the scientific literature over what caused this transition. And I've written about this in several blog articles. It's going to be in my book, Weathering Climate Change. I'm convinced it's not one cause, it's multiple causes.
Okay.
14 causes have been identified as being possible. I believe it may be conceivable that over 12 of the 14 that have been suggested all play a role. And
so if you've got that many factors at play, you could almost argue this may have been designed or intended for that purpose.
Exactly.
If you will.
When you got that many that have to happen simultaneously at just the right levels, this looks like supernatural design is playing a role here, especially when we realize this is crucially what's needed for billions of people to be able to hear and respond to the gospel message.
So in order for Earth to be inhabitable with as many people as we have, we need something like these long interglacial cycles.
We do, and we need the stability.
Right.
We need
and
both.
Then to get the long interglacial, or the longer cycle, we need multiple factors at play to make it happen.
Correct.
Can you just, I don't want to go through all of them, but give a couple that are maybe the easier to understand that what might impact the length of this?
Well, one thing we know for sure is that one of the big factors was a drop in the atmospheric carbon dioxide level.
Okay.
However, there's multiple ways that could have happened, and I'm convinced we need several factors to bring about that drop.
Okay. So you got a drop in carbon dioxide.
Right. Another thing is that there was a major asteroid or comet that hit the Earth 800,000 years ago, and this played a role in dropping the oxygen level.
So, okay, so you got the carbon dioxide dropping, you also have just the oxygen levels dropping. Is that what you're saying?
No, the oxygen level doesn't drop. It's a carbon dioxide level.
Carbon dioxide level that drops.
Carbon dioxide levels drop, but if you get an asteroid hitting the Earth, that's going to have a cooling effect.
Okay.
That cooling effect is going to cause more carbon dioxide to be absorbed in the ocean. The other thing is you get dust.
Okay.
And there's actually several models that have been proposed of different sources of dust that basically enrich the oceans with iron that cause the phytoplankton there to draw more carbon dioxide out of the atmosphere.
So you increase the biological activity, that also impacts the carbon dioxide.
That will pull the carbon dioxide out.
Okay.
So
one more, I'm going to refer people to your blog, and they're going to be able to look at all of them. One more example of something that impacts this, or likely impacts the cycle.
Well, what's been happening in North America in the ice ages, because with each successive ice age, we get North America being covered with more ice and thicker ice.
Okay.
And we also noticed that with the last ice age, it built up quickly and receded quickly. And so one point is making, hey, the rapid deposition, especially the rapid disappearance of the ice. I mean, thousands of feet of ice disappear in less than 1,000 years.
That's pretty remarkable.
Pretty remarkable, and it's unique to the last ice age, and it goes back to the 800,000 years ago when this transition happened. So I think that plays a role, and also explains why every successive ice age has been a little more severe than the previous one. But the bottom line is, Jeff, this is really complicated. 14 factors have been suggested. I'm not even sure we've come up with a complete list.
Right.
There may be more there, because 2 of those 14 were discovered in just the last 6 months.
So, random question here, just kind of related though. How long do you think it will be before we go to the next ice age?
Well, that depends. I mean, we see in the previous ice ages, it looks like the melting of the polar ice cap is what kicked off the coming of the ice age. That's what's kind of paradoxical.
So you get warming to the polar ice caps melt, and that actually precipitates the ice age.
Global warming always brings on an ice age.
That's a little counterintuitive.
And if you look at the previous ice ages, whenever the temperature hit a peak, about 2 degrees centigrade above where it is now, a rapid drop into a long-lasting ice age.
All right.
And the thinking is the melting of the polar ice cap plays a role, because if you melt the polar ice cap, that causes a lot more snow to fall in Siberia and Canada.
Okay.
And that's what.
So you think we may not be too far off? So.
Well, it depends. I mean, we can preserve the polar ice cap. I think we got a chance to, stave it off for another 1,000 years or so.
We tend to think of ice ages as a bad thing, kind of destructive to the planet, but really it's an important aspect of how the Earth is habitable for humanity. And it looks like God has orchestrated things so that ice age cycle occurs in a way to allow humans to thrive, especially at this time and at this place. I'd encourage you to go to reasons.org, search for Hugh's articles on this. And if you search for Pleistocene, that's Pleistocene, you'll get links to a number of articles where Hugh explains why these ice ages are important, how they point to a creator, and how you can use this evidence to go out and share the good news of the God of the Bible.